Now we're going to look at working with composite objects. And all that means is working with multiple geometric figures. In example 1, let's determine how much metal is required for the construction of one of these silos. So we want to determine the surface area of the cylinder, the outside of the cylinder, and then the surface area for where this cone is, but only the top portion of the cone. Because we see that metal is not required for where the base of the cone, that's here, meets the cylinder. There's no circle underneath the cone that's covering it. And then where the cylinder meets the ground. Again, there's no circle at the bottom that's made out of metal. So we have two shapes here we're looking at. We're looking at a cone, and we're looking at a cylinder. And for both of these, we're trying to find the area, the amount of material required. So 1, we're going to find the surface area of the cone, or the top part of the cone. And then 2, we're going to find the surface area of the cylinder. So what we need now are the formulas for the surface area, the top part of the cone, and for the sides or the outside of a cylinder. So if we go to our formula sheet, we see we have our cylinder here and our cone here. Notice we're looking for surface area. So for a cylinder, it's the surface area of the base plus the lateral surface. Right? So the surface area of two circles is the top and the bottom, so we don't need this portion here because remember it's open. So we're just going to use this right here, the lateral surface or the outside, that's this part here. Because remember, in our silo, the top and bottom of it is open. So we need 2 pi RH, that'll be for our cylinder. And similarly for our cone, we don't need the base part because that part will be open. We only need the surface area of the top portion. So that's pi RS, where S is the slant height of the cone. And notice, if we have the height of the cone and its radius, we can use Pythagorean's theorem to get the slant height. So let's go back to our diagram. So let's start with the cone. Alright, so first we're focused on the cone. So here's a big picture of it. But we're going to need the height of the cone as well as the radius of this cone. So first of all, we can see the height from above, since the total height is 7 and the height of the cylinder is 6, that this is 1.0 meters. That's going to be the height of the cone. Next, we can find the radius of this cone, and the radius is just going to be half of 4.75. So here's 4.75. Half of that is the radius of that cone, which gives us 2.375 meters. But remember, for our formula, we need the slant height, S. So S is, we're going to need Pythagorean's theorem. So we're going to have S squared is equal to H squared plus R squared. And therefore S squared is equal to 1 squared plus 2.375 squared, which gives us an S squared value of approximately 6.64. And then if we square root our answer, we're going to get S, the slant height of this cone, is equal to approximately 2.58 meters. So that's this here, 2.58 meters. And now with that information, we can find the area of that cone. So the area is equal to pi radius times slant height. So that's pi. The radius is 2.375 times the slant height of 2.58, which tells us that the area, or the outer area of a cone, is equal to approximately 19.25 meters squared. So that's the area of region 1. Now let's take a look at the cylinder. Remember the cylinder, we're just looking for the outside area. And we know from our diagram above and from what we just shown here that the radius of this cylinder, halfway point if you like, we've already calculated to be 2.375 meters. Remember, that's half of this 4.75. And we see from the picture the height is 6 meters. So that's here. The height is 6.0 meters. So using again our formula, the area of part 2, or the outside cylinder, is 2 pi r h. So that's 2 pi times 2.375 times 6.0. And this tells us that the area of our cylinder, or the area of the outside of this cylinder, is approximately 89.54 meters squared. So the area total, or the total area, is equal to the sum of these two areas, which gives us 108.79 meters squared per silo. Alright, so that is all part A. Let's go to part B. How much grain can be stored in 4 of these silos? Notice now this is not the same question. The one was the amount of metal around it. This is now how much can be put into it, so we're looking for volume in this question. So now we want the volume that 4 of these silos can hold. Let's find the volume of each space. So let's go back. We have a cone. We need the volume for a cone. And then next we'll look for the volume of the cylinder. So now we need to go back and look at our formulas for the volume of a cylinder and the volume of a cone. So back to our formulas here. We see that the volume of a cylinder is pi r squared h. And the volume of a cone is the same thing, pi r squared h, but just divided by 3. So it's 1/3 the volume of a cylinder. So let's write these down. So we have volume equals pi r squared h divided by 3. And for the cylinder, volume equals pi r squared h. So for the first one, we get pi. If we go back, we saw that the radius is 2.375. So using our answer from A, 2.375 squared times the height of the cone, which was 1, all divided by 3. So remember, here's our diagram here. We said that h was 1, and there's the radius. And for the cylinder, we have a height of 6 and the same radius, 2.375. So volume equals pi times 2.375 squared, and then times 6, and we don't need to divide. And all we need to do now is use our calculator to determine the volume of each geometric shape. So for the cone, I end up with 5.91, and since we're dealing with volume, that would be meters cubed. And for the cylinder, I end up with 106.32 meters cubed. So our total volume is going to be the sum of 5.91 and 106.32. So the total volume is equal to 112.23 meters cubed. That is for one cylinder. So for 4 cylinders, we're going to do 4 times that volume total, and that would be 448.92 meters cubed. So therefore, 4 silos can hold approximately 449 meters cubed of grain. All right, last example. Determine volume of the given object. So again, identify your objects. So the top one is what we call a triangular prism. And then the bottom one is a rectangular prism. And if you're not sure of the names, remember you have the formula sheet with the pictures to help you with the names. For our triangular prism, we see that it has a height of 10 feet. And we also see it has a base, given here, of 310 feet. For our rectangle, we see we have a height of 25, a width of 310, and a length of 280. So again, let's go look at the formulas. So our rectangular prism, the volume is the length times the width times the height of that rectangular prism. And a triangular prism, the volume is the base of the triangle times the height of the triangle, then times the length of that prism. So I remember it as the area of a triangle, so base times height divided by 2, times the length of the object. So our volume for our triangular prism is going to be base times height, then times the length, so we'll say that's L, all divided by 2. So for our example, the base is 310 times 10 times the length of that prism, which is 280, all divided by 2. For the rectangular prism, we have length times width times height. So we can say the length is 280 times the width is 310 times the height is 25. So let's figure out our two volumes. So for the top portion, we end up with 434,000 feet cube or cubic feet. And for the bottom portion, we end up with 2,170,000 cubic feet. So we're going to add these two up, and we get a total volume equal to 2,604,000 cubic feet, or feet cubed. Would the barn be large enough to store 50,000 meters cubed of hay? And you got your conversion factor there. 1 foot equals 0.3048 meters. So we got our conversion factor. We know that 1 foot equals 0.3048 meters. But now we need to figure out how much does a cubic foot convert to. So to figure that out, a quick way to do that is just to cube both these numbers. So we get 1 cubic foot, 1 foot cubed is equal to, and you're going to take the cube of 0.3048, which is going to give me 0.02832 approximately. And that's going to be meters cubed now. And then what I'm going to take is my volume from above. So the 2,604,000. I'm going to times it by the 0.02832 to convert it into meters. And that gives me 73,745.28 meters cubed. So the barn itself can hold 73,000 meters cubed. So yes, it could hold 50,000. Try these questions out and contact me if you need any help.